The present video is intended to give you a brief introduction to some of the functions from the Statistical Tools plugin, including the generation of random numbers and the calculation of some statistics. In some upcoming videos, we're going to present more details on this. This is just a brief introduction to the subject. For that, we're going to go into this worksheet. And we're going to start by talking about functions that are available in the statistical plugin. In the calculation of statistics, for example, we calculate things like the mean, the geometric mean, the harmonic mean, and the weighted mean, the median, the mode, moment, standard deviation, variance, skewness, kurtosis, etc. We talked in the last video about probability mass function and cumulative distribution function for the binomial distribution. There is also the quantile function, which is basically the inverse cumulative distribution function, and this will be presented in more detail. But there is a variety of discrete distribution like the binomial, and discrete and continuous distribution like the Cauchy, chi-square, exponential, normal, Poisson, Rayleigh, and so on. These are going to be discussed in more detail somewhere. For random number generators, we have functions random and random n to generate uniformly distributed numbers. If you want random numbers that follow a particular distribution, you can generate uniform numbers with these two functions and then use the inverse cumulative distribution functions. And so, some examples of applications. The function random n, which can be found using fx in the all functions under the R, random.n, or you can type in random.n, can be used to generate one single number or a vector of numbers or a matrix of numbers. If you use 4 arguments like I use in here, you're generating a matrix of numbers, of random numbers, uniformly distributed. This is a matrix with 5 rows and 10 columns for numbers uniformly distributed, between 0 and 100. Now, you look at that particular matrix right there, and I'm going to generate a different one using exactly the same command. If I do Control C here and Control V and then say equal, you can see here that the matrix that I generated is different. That is the nature of random numbers. You generate numbers like if you were throwing dice or doing some other kind of statistical game. And so every time that you use that function, you generate a different set of random numbers. As a matter of fact, if I just do a recalculate, then my matrix changes. So that's the nature of random numbers. And so what about statistics of that matrix? The length of the matrix we know is 5 by 10, so it's 50. That can be calculated using the function length. That's not a statistical function. It is simply the number of elements in a vector or matrix. But these are functions that belong to statistics. The mean value, the geometric mean value, the median, the standard deviation, the variance, the skewness, and kurtosis. Those are presented in statistics. I'm just giving you the names of those functions that are available in this particular package. If I use the function random without the n, these are numbers between 0 and 1. And all that you provide is the number of rows and columns in the matrix that you want to generate. This one has 5 rows and 6 columns. Now, these are uniformly distributed numbers. Between 0 and 1, it could be thought of as a probability. So if you wanted to generate random numbers that belong to a particular distribution, like the normal distribution, you can use the function ICDF, which is available under the I here, ICDF normal, for example. And in this case, I'm using 3 arguments. The first argument is that matrix R, which gives me my matrix of value between 0 and 1, sort of representing a probability. And this is the mean, and this is the standard deviation of that normal distribution. I use the vectorization, and it gives me numbers that follow the normal distribution, random numbers that follow the normal distribution. Then I proceed to calculate for these steady numbers the mean. I mentioned that the mean was 5, right? The mean of my sample is 466, which is 10 into 5. The standard deviation 1.93, a little bit different, but close to the standard deviation that I use to produce the random numbers. And so this is, and of course these are other statistics of that particular sample. I just wanted to show you, give you a preview of the kind of functions that are available in the statistical plugin package, in the statistical plugin for SMath Studio. With that, we conclude this particular video.